It's just a quick video on the first assignment, technology assignment A. So if you click on the side panel here, you see technology assignments. You should see technology assignment A. If you click on that, it brings you to a file, which is entitled Tech Assignment A Discontinuities. I did a guided example here, but I'll just walk you through that real quick because there's like a lot of screenshots. But the idea, and I did one for a trig instance also. What you're going to do is basically what I show you just for these four functions. Now you have a choice. You can try to do it all in one Desmos, but my recommendation would be that you do a Desmos for each one individually. All right, but let me walk you through it so you know what I'm talking about. First thing you're going to do is go to desmos.com. All right, I'll plug in this function, but let me go to Desmos. If you click on that, you're going to want to create an account. They don't harass you with emails or anything like that. So Desmos is completely free. I don't know if it'll always be completely free, but as long as I've been using it, which is years now, it has been completely free. And they don't hit you up with ads or anything like that. So you don't really have to worry about creating an account and then getting bombarded with emails from them. So anyway, if you click on, so create an account, click on Math Tools, you'll see Graphing Calculator. So click on that. There's other options here too. You might want to consider playing around with these other options as you go forward in your math education, but for our purposes, we're just going with Graphing Calculator. And it brings you to this empty slate, really. And so if I type in a function, let's say I type in like y equals x, once it recognizes that it's an equation that can be graphed, it'll graph it. The good thing about Desmos, better than a TI, is that something like a conic section, like I'll just do a simple circle, it can graph that even if it's not a function, right? So it doesn't pass the vertical line test, it'll still graph it, right? So that's a nice feature. This little gear thing here, if you click on that, it allows you, it really, I mean, it doesn't seem like it does much, but if you type in something that's fairly complicated and you want to duplicate it, just so you can make like a small edit, then you would hit that gear thing, right? So, but for our purposes, I'm just going to type in f of x is equal to x squared over x cubed minus x. So, like, just type it in. F of x is equal to, now the caret symbol, shift 6, will bring up a power of 2. So if I do x, then shift 6, you see it becomes an exponent, power of 2. To get out of the exponent, just hit the right arrow, divided by, I already forgot the denominator, x cubed minus x. So x caret to the third power minus x. You could also use the keypad here. For simple things like raising to a power, I tend not to, because I think it's more trouble than it's worth. But if you use the keypad, it would be right here. I suppose if you're using this on a tablet or something involving a touchscreen, then where the keyboard is probably, like a physical keyboard is probably not the most user-friendly, then you would almost definitely want to go here. If you click on functions, you can see all the different things that Desmos has to offer. Right? So you can just scroll through that and try some things out, but for our purposes, we don't really need too much of that. Look for discontinuities in the graph, right? So we see that we have a break here at it appears to be -1 and a break here at +1. Now the denominator is degree 3, so there could be a third discontinuity, right? I'm seeing 2 asymptotes. If I zoom out, right, a little minus button, that doesn't really help, but at a minimum, I'm not seeing a third asymptote, right? So if there is a third discontinuity, it must be a hole, all right? So I'm gonna go and create a slider, all right, and then plug in whatever values in that slider to the function and see where the values are undefined. All right, so I'm going to just type in, you type in really anything, a equals, just pick a number, I'll type in 0, and it gives you, basically, it creates a slider for you. All right, so if I hit enter, I can scroll back and forth. Now a can take on any values between -10 and 10. Maybe I don't want to go that far. If I want to make a change, I can make this -5 because I'm looking at my screen here. I can go -5 to 5. I can go further if I want. I could also change the incrementing. So if I want to go by ones, for example, then I change the step to a 1 and it'll only go by ones. All right. Not often the case that you would need to do that, but it's nice to know. All right. So I'm going to type in f of a. So that's evaluating the function for whenever the x value is equal to the a value, which in turn is equal to 5 in this case. Right? I see I have a real value. If I scroll left, still real, 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 undefined at x equals 1. All right, that's the location of vertical asymptote. So I'm just going to make a little note here as I go. I'll just kind of put it down at the bottom. If you open a quote, it'll give you the option to produce a note. If you, oh, sorry, I hit the wrong thing. If you hit that little plus where it says add item, you'll see that note is an option there also. All right, but I'm going to say vertical asymptote at x equals 1. All right, I'm going to continue scrolling. At 0, I don't see an asymptote, but it says it's undefined. All right, so that must be a hole at x equals 0. All right, I'm going to continue scrolling. Now, you could probably already see the drawback to this approach, just like with the TI. If you go into the table, if the hole's at a fractional value and you don't have it set to go by decimals or fractions, then you might not pick up on it. All right, but here the values are nice and neat. I see that I have a vertical asymptote at -1. I see it's undefined and it corresponds to what appears to be a vertical asymptote. So I'm going to say x equals -1, x equals +1. All right, just continuing the process. I can get the coordinates, right? The y value corresponding with the a value, all right? So verifying the asymptotes is fairly easy, but basically what we want to do is we want to create a table surrounding each point of discontinuity, all right? So I've already done this part, so that's good. But I need to do the tables because I have to verify locations. Now, visually, it appears that the y value corresponding with this a value of 0 is also 0, but I need to confirm that. All right, so what I'll do is I'll create a table, and I want my table to surround my first discontinuity. All right, so my first discontinuity is at -1. So I'm going to go a little bit less than -1. So if you look at the tables that I did here, I subtracted off 0.0001. 0.001 would be fine. 0.0001. You can go as far as you want as long as you get meaningful values. All right. So I'm going to do -1 minus 0.0001. Sorry. I'm going to do 0001, but I'm also going to do 0002 and 0003, but I want to have it in increasing order. Let me do the 0003 part first. All right. Then -1 minus 0.0002 negative, and it assumes what I want to do. It notices the trend, so I can just hit enter now without having to retype the values in. All right. Now the y value that I get here is going to be f of whatever the x1 value is. All right. So the x1 value are the values that I put in this list. And you can see it confirms that it's undefined at -1, and it's extreme in the negative direction. This is basically the calculator trying to say that it's going to negative infinity, and it's extreme in the positive direction, so that confirms the first vertical asymptote. All right. Now, if I go and hit that gear thing, I can duplicate my list, and instead of surrounding -1 with subtraction and addition of 0.001 increments, I can do it for 0. So if I just wipe this out, that'll get the job done. All right, so this would be 0. Oops. Let's see here. This would be 0.0001. 0.0002, oops, and then 0.0003. All right, and you can see here that this is scientific notation saying that the decimal value is 0.0001. All right, and on the other side, it's negative 0.0001, which means, and we'll get into the squeeze theorem as we go forward, but it's basically saying that whatever this y value is has to be between this number and that number. And the only whole number that exists between these two decimals would be 0. If you're not sure, you could even dial this down further, throw in some extra zeros. Not required, but it gives you a better sense, because now it's saying just below this y value, or I'm sorry, just above it is 0.000001, and then negative 0.00001. All right, so that's confirming that the whole is at the coordinates 0, 0. And then I would essentially do the same thing just with the 1. So duplicate the first one, because that's a little bit more user-friendly. I'm going to slide this down so I have it in increasing order. It's not really required, but it just looks nicer. All right, so then I want this to be +1. And you'll see that the relationship that emerges is essentially the same as -1, where it's extreme on either side of 1. The calculator's doing its very best to try to say that it's approaching infinity. It just doesn't have the vocabulary for that. So that's this is confirming that to the right of the value, and really honestly, I mean, if you want to go below on one side, above on the other, that's fine. Let's see here, actually. Yeah, that's essentially, no, actually these values are the same. So let me actually do this using a technique I like to call the right way. All right, so this one should be 1 minus, then 1 plus, sorry, 2.
Wait.
And then 1.0003. All right, so that confirms the asymptote at the x value of 1. So at this point, what you're going to do is save your work, then create a share link. You'll see share graph. It'll create a link, copy that link, and dump it into Brightspace.